Hi all, and welcome back to part 2. In this part, we're going to be talking about loading data using readlines and numpy. So the first step of loading data is having data that we actually want to load. Here, I have a sample data set, a Seattle tidal record from NOAA Tides and Currents. Their website offers some user inputs for date ranges and data interval, and I went ahead and put in October 1st of 2020 up to October 24th of 2020, and a data interval of every 6 minutes. When I do that, I hit the data only button, and it prints out something like this on my screen. So I have all of the data right in front of me. But there's also a button that says download txt, which means that we can download this data as a text file and later use it in Python for plotting or for data analysis. The next step is just to link it to Google Colab, like we did in part 1. So remember, from part 1, you can either upload to Google Drive and then mount your drive to get your folder, or you can upload directly to Google Colab. The only difference between these is really going to be the file path when you're calling your file to read it. For clarification, I did use the Google Drive and then mount my Google Drive. So my path is going to be a little bit longer because it's embedded in the drive rather than just available here on the file system. So now that we have our file and it's linked to Google Colab, we want to get to know a little bit more about our data. Our file itself can tell us something, right? It tells us its path, and it tells us its size, so we can get sort of an idea of how much data we're looking at. But it doesn't really tell us what it looks like inside, and especially the structure, the variable names, and that kind of thing. So we want to look inside, and there are a couple ways to do that. One way is to open the file using a text editor. Note that Microsoft Word is not a text editor. So when you open it with using a text editor, it prints it out and it's human readable, right? You can see all of the header information, and down below there's going to be a lot of data sort of streaming out below in columns. The only downside to this is that it requires an outside application, and that can get kind of tedious going back and forth between things. So the other option is to open the file using Python. So here we have our file path, and note that mine is long because I mounted my drive rather than just uploading to Google Colab. And in order to open the file, we use the function open. So we say open our file path, and then we give it this little R here, and that means that we're going to read the file. Now, note that open does not read the file. Instead, it just creates this file object that can be read later or used later on. Think of it like opening a book. When you open a book, you don't immediately get all of the information into your brain, right? You don't just immediately read it there. You have to sit down and read each line. Python's a lot like that. So we have this file object after we've opened it, and now we want to read it. We can do that using readlines. So again, we have our file path, our file object that we open, but we haven't read it yet. And then we say a variable lines is equal to our file object dot readlines, and then parentheses to make it a function. What this function does is it loads the entire file into memory, and then it'll return a list with the variable name lines, and that list contains each of the lines as list items. So the next step, after you've read the file and you have all the lines, you want to close your file. You want to do this so that you aren't keeping it open and overwriting your work or overwriting your data. So once you've closed your file, you can sort of look at your lines. You can say print lines, and you can print the length of the lines, and you can see that we have all these lines, and it's in a list format. So there's the first line, the second line, and it's kind of a longer line. And then we can print the length of it, and you get 5,774 different lines. It's not very easy to look at all of these lines, right? You have to scroll over a long way. It's a big, long list, and there's a lot of header information on the top, so it's hard to get to the data right away. Plus, when you have a file that's really, really big and you use readlines, it's still trying to read that whole thing into memory. And that can take up a lot of memory, which can have issues for Google Colab, can slow down your code, and isn't ideal. The alternative is to just use readline instead of readlines. So readlines reads the whole file at once. Readline reads each line as you go. So every time the readline function is called, it reads a new line. So here we have a file path, the same file. We create our file object by opening it. We still have to open it. And then we say for I in range of 30, line is equal to our file object dot readline, and then we print out that line. So what this is doing, that every time the loop goes around, it's reading a line. So on the very first iteration, it's going to read the very first line. On the next one, it's going to read the second line. And the next one, the third one, the fourth. So the end result is that there's going to be 30 lines of this file printed out, but not the whole thing is going to be saved into memory. So we can get an idea of what it looks like without having to open the whole thing. And then the very last step is to close that file object. When you run this code, you get an output that looks a little bit like this. I divided it into two sections here, the header and the data, but normally they would just be right on top of each other. So here we have our header information and our data, and now we can see the structure of this file. And now we know quite a few things. We know our path on the Google Drive. We know that there are now 14 lines of header information if you count them out. There are 14. And that header information has really great details. It tells us about the station, the state it's in, the units. It tells us about the time and the frequency that it's taking measurements at. So that the header information is really useful. The data columns also tell us some information. We know that columns 0, 1, and 2 are all date information. So here we have the date, the day of the week, and the time. We also know that column 3 has floats, right? So they're just numbers. And then the columns are separated by white space, as opposed to like commas or dashes or things like that. So using all of this information, we can extract that data using a numpy function, genfromtxt. What this function does is it takes all of those elements out of the data file and it puts it into a numpy array. We have to consider the file structure to properly load the data, which is why we opened it up to look at it and get this information. So to start us off, we have import numpy as np, because it is a numpy function. And then we have our file path, same file path. And then we say data equals np.genfromtxt. And we're going to start building our arguments to load in this data. So here we're going to start building our arguments, and we're going to use our information that we know about our file. So first, we know our file path. And genfromtxt requires us to tell it what file we're going to be loading. So we give it our file path. The next thing we know is that there are 14 lines of header information. Now, unfortunately, genfromtxt can't differentiate those things. So we just want to skip the headers and just get straight to the data. And we do that by saying skip header with an underscore there equals 14, which is the number of lines the header information has. If you have a file with different number of headers, you're going to change that number. And the next thing we know is that columns 0, 1, and 2 are date information, and column 3 has floats. And if you remember about numpy arrays, they can only have one type of data in them. So we're actually going to load these as two separate numpy arrays. And we're going to start with the third column here. So we're going to say use calls. So that's saying use this column. And we're going to say that's number 3. And we're going to give it a data type or D type, and that'll be a float. The final thing we know is that the columns are separated by white space, which means that there's not a delimiter. If there was a delimiter, we would want to put that in as an argument as well. So this is for just the data from column 3 with the floats. And now we have to create the one for our columns 0, 1, and 2, our date information. And we're going to load those as strings because note that they're not date time objects. They're just sort of date information. And we can later turn them into date time objects using some of the stuff we learned in the last lesson. And notice that our use calls, we're feeding it a tuple here. So we have a 0, 1, and 2, and that's surrounded by parentheses. So putting that all together, we have our import numpy as np. We have our file path, and then we say data equals np.genfromtxt, our file path, our skip header, our data type, our columns that we're using, and our delimiter being none. Now, those delimiter being none, you don't have to put that in. Now for the time data, we have np.genfromtxt, our file path, our header, our D type as a string now, our columns that we're using, 0, 1, and 2, and again, our delimiter being none. So now you can print out that data, and we see that they both have the same length. This one is just all our floats, and that's our predicted sea level. And here we have our strings for our date information. So we've successfully loaded this data. Now, if you get a little bit lost about those genfromtxt arguments, we don't expect you guys to memorize those. You can actually go and look up the genfromtxt information and the official documentation from NumPy. And it actually gives you a lot of customization options. So if your file has a lot of weird variables, has some missing data, you can account for those in genfromtxt. The things in blue here are the arguments that we put in, but there are so many others, and the documentation tells you what each one of those are. So feel free to read those if you have a weird file that you want to read in. That's it for part 2. Don't stress too hard about reading in stuff to Colab. We're going to go over it a lot on Monday and do all of these as examples in class.